Okay, hello, this is Rani Ahmed with you. This is lesson 17 and using Objective-C as a programming language for the Macintosh operating system. Okay, in this lesson I'm going to talk about what are objects, what are classes, what's Objective-C exactly, okay, because all what we have been doing till now, okay, after the last lesson was just pure C, okay, has nothing to do or deal with Objective-C at all. Okay, but Objective-C is C in reality, okay, but it has its own way to define what we call objects and classes. Okay, now Objective-C is a language or emerged from C by two people, okay, or two persons, and those persons they invented that language called Objective-C because at the time everything was everybody wanted to make C a language that has object orientation or the power or the technology of object orientation, okay, or object oriented programming. So what did they do is like using objects, I can, for example, define many things and include the attributes and the functions, okay, or the functions or the what we call the messages or the methods, okay, instead of using the word functions, okay, to the definition of an object, or as we used to use in the past, a definition of a structure. Okay, so for example, everything in this world is an object, okay, but you have like a common general map of all objects or all structures, okay, but here when we deal with objects, you have to understand that the functions are included within the definition. Okay, now in this lesson I'm going just to talk about it, okay, and I'm going to do a little bit of like a hello world program. So what we start with is like this. First, before starting with Xcode, I must also explain more about objects. So this is our diagram, okay, which will be used to explain objects more. And in this this diagram, like for example, as I told you, everything in this world is objects, and there's a general blueprint of all objects in this world. Okay, every type of this of any object in this world. For example, if I take an object, maybe it can be a car. So the car can have an engine type, a number of windows, a number of tires, okay, and it has some functions, okay, or methods or messages, as in the way Objective-C says, okay, because Objective-C uses the word messages more than they do with methods. Okay, other languages like C++ and Java use methods, so use the word method. Okay, so in Objective-C I have also the functions, or what we call the messages here. Okay, so I can send a message to the object, okay, and the object has to deal with that message. For example, like start an engine, I'm telling it to start an engine, so this is my message to it. I'm telling it to stop an engine, for example. I'm telling it, for example, to turn right, turn left. Okay, so those are representations of the true functions. Maybe you have your system uses true machines, okay, and if you wanna represent your machine on a program, you have to do it this way, okay, and therefore the code for example, stop an engine and setting the engine type and the number of tires, okay, it's all represented in your code. Okay, so all of this will go under one entity in your code, under one paragraph. Okay, now so let's start our Xcode, and he will start. Now I have here create a new Xcode project, of course. So I start with this, then I say command line tool, okay, because I want to write command line applications, which are like terminal applications. You already know it. And here I want to call it classes, okay. And by the way, you will have to use the type foundation, okay, because we are not using anymore just C simply, okay. We're using we're using foundation, okay. Now next, and here in this folder named documents, which I'm highlighting, okay, I'll be creating the folder named classes, which will hold all the codes of my project. Good. So, and I don't want to create a Git repository, because I don't want to make anything for production, like to revise my code and make revisions and make versions of my code, okay. So I just press create. Now the first thing we notice, okay, and you should notice, is that when we started our program, or our project, I mean, the program has the main file. Now the main file in C usually it has the name main.c, okay, but here it's main.n. Objective-C uses .m instead of .c as its default code extension, okay, file type. However, headers are still the same .h, okay, because it's still C, okay, but just like they want to make it like for Objective-C, make it .m, okay. And the difference that you will notice that we don't use it's not a must, okay, it depends on your compiler, okay. So in Objective-C, you have to, or you're advised to use import instead of include, okay. And the older include, like we used to do this, like include, okay, and the header file, for example, stdio.h, okay, both work, both are the same. However, I advise you, because we are using Objective-C, to use import, okay. We'll be using stdio, okay, within our code, but I want to show you more Objective-C, and little bit of with stdio. You'll see how C and Objective-C are almost the same, okay. It's just like they developed C into a better C, okay. Now the auto release pool is like the variables are automatically released, okay, and they will be freed from the memory automatically, okay. Now NS log. Now what's NS? Okay, NS means first, like what we are writing for the interface is named next step, okay, that's why the NS, and it's made by the company named next, okay, which is just styled like this, okay. So which is the company established by Steve Jobs after he left Apple, okay. So that's why you will be seeing so many NSs in your Objective-C code, okay. Now in here I have NSLog. So what's NSLog? NSLog is like printf, but you have to understand also that when you are using Objective-C, you must have this definition, this header, okay, otherwise there will be no Objective-C, okay. So I have a folder named foundation, and I have a header file below this folder named this file, header file is named foundation.h. Okay, and they are found in the default or the directory that's in the path of the compiler. Okay, in the include path of the compiler. Okay, so same as stdio.h. Okay, now what I want to talk about more is that this NSLog is much like the printf. Okay, but this one has a difference, is that you must precede the string, which we all the time use double quotes to define a string. Okay, you must precede it with the @ sign of the email. Okay, that you usually type it with the email, the @ sign. Okay, and here is a test of this code. Okay, so this is what we got. I have a hello world. So to give you more proof that it is very much like printf, it's like this. This is another run, but using an S, you will be using more Unicode. You can have any kind of language you can type. Okay, now you can also okay, now what I'm going to do is put printf, and I'll show you that printf and NSLog are almost the same, but NSLog, as I told you, it can have more languages. You can add Arabic to it, you can do anything like that. Okay, so this is printf because I included I will be including or I added stdio.h. okay, I can have here printf, so printf, and I will be copying this sentence and I'll show you they are the same. I know you know printf, but it's good to see them both working together. And of course you must find it with a semicolon, and there is a run. See, both are having hello world, but the difference is that in NSLog you're getting the date of your, or the time of the run of the program, like the time this message was sent, this string was displayed on the shell. Okay, because everything in NSLog and printf will go to the terminal, okay, to the shell, okay, to this shell, like if I do really run it. Okay, now I'm going also to define two variables and show you. One is a double, one is a number. Okay, I'll show you an integer number and show you that I can do the same with as we do with printf. Okay, so this is int and num, okay, equals 3, and I have double 6.dn equals 6.3. so to add more and show you that .2f works too. So this is this is num equals %i, okay, and here I have what else? Of course I have dn equals %.2f, okay, and let me add a comma here. Okay, and then this is num and this is dn. What else? Then I just copy this because it's the same, so I say Ctrl V, and that's it. I'm saving. So running it, see, I had 6.35, okay, 6. Now it's approximated to 6.3, and both are working the same. So This is for now. Okay, next lesson we're going to start with true classes and true working classes. Okay, and I hope you liked it. Okay, see you in the next lesson. Please subscribe and your comments.